Yeah, so in this slide, let's talk about surfaces as datum features. We talked about this earlier, but let's keep talking about it. Primary datum surface is listed first in the feature control frame. So the primary is listed first and establishes the first plane of the datum reference frame. The secondary and tertiary datum planes are mutually perpendicular to the primary surface. Now, what does this look like? Okay, when you're calling this out on a drawing, here's what it'll look like. We have our primary datum here. Okay, and here's how we know what primary, secondary, and tertiary is. Looking at this feature control frame here for this positional tolerance. Okay, so A obviously is the biggest surface, so we're going to use that one. And we have a profile tolerance on that surface, and then we put the datum next to it. Datum B is defined over here. We have a perpendicularity tolerance on it. Back to A, and then C is this surface here. What does that mean when we simulate the datums? We're going to have these tooling points, which would be these datum simulators, which really creates kind of like a nest for us to butt this part up here against these three datum planes. And what that really establishes for us is a reference frame, as we're seeing in this picture right here. So the tertiary datum plane is perpendicular to the primary and secondary planes and is located by the tertiary datum features on the part. Okay, so that's why we know this plane's over here, except not on the other side of the part. Okay, so this tooling feature, this tooling datum simulator, is something that we would use to either hold the part for drilling the holes, because you're setting the part up just like the datum reference frame is set up. So that's would be the clue to the manufacturing engineers that that's how I tool the part for drilling this hole into proper position. And then it's also used, something like this can also be used for inspection of that hole position. Okay, so here we have an actual simulator for a datum surface. Okay, and this could actually be what we're going to call a functional gauge in some of the other slides going forward. But yeah, this is an actual gauge that would check the position of those three holes here relative to the three datum surfaces: datum A, datum B, and then datum C. So we can use this as a tool to check the position of these holes. Let's talk about interrupted surfaces for a little bit. In which case, we have this surface, this part here has this lower datum surface A is actually three surfaces. So interrupted surfaces establish a single datum feature by applying a profile tolerance and a datum feature symbol. So that's how we do it there. If the number of surfaces is noted on the feature, number of surfaces noted on the feature control frame if multiple. Okay, so three surfaces over here act as one. So these three surfaces are associated with the feature control frame and datum feature. So the datum feature must be referenced in a feature control frame or note for its identification to be relevant. Yeah, you can define datums all over the drawing, but if you don't use them in a datum reference frame, they don't mean anything. Okay. Let's talk about cylindrical datum features. Okay, these would be features of size. So shafts, holes, and other cylindrical items may be identified as features of size, datum features of size. Here's how to apply them. With the model, we use the dot, but on an orthographic view, what we'll do is, we show two ways to do it. One is to replace the arrow from one side of the dimension line with the leader and the triangle for the datum. The other way to do it is to apply the datum triangle directly to the leader. That's another way to do it. Another way to do it is just apply it with a leader. Okay. In this case, we applied it with a leader where we had the dimension. Another way to do it is to apply the datum triangle directly to the feature itself, like we're seeing here. That's an internal feature of size. And then the placement significance. This indicates the pattern of features establishes the datum. Okay, so in this case, the 2 by becomes our datum, not just one. That's a little advanced topic, but I just thought I would introduce that. Okay, so that is how to apply a datum identification to a feature of size. In this case, external feature of size, and in this case, internal feature of size. Let's talk about interrupted. This is kind of an advanced topic, but interrupted cylindrical features. And interrupted features can act like a single feature in design applications. So in this case, we have these two features here, but we're going to use the continuous feature symbol on it and applied to indicate the single feature. Interpretation could be as multiple features without the CF symbol. So we're going to call these two features as a single feature using the CF symbol. We place the CF symbol by the dimension itself, and we placed it again over by the datum. So let's talk about how we would simulate a cylindrical datum. Okay, so a lathe chuck or collet, usually sufficient to to simulate a cylindrical feature. So in which case a datum simulator like this, a chuck draw, would pick up this datum feature, this imperfect geometry. Okay, if it would tighten up on it, and then you could pick it up that way. And that would establish a datum axis, a theoretical entity about the center line of where this chuck was. Okay, so in which case we have this imperfect shaft here. We have the feature axis, which is the actual mating envelope. That's this actual mating envelope would be this true geometric counterpart of the part. And then when you talk about the datum features, we have imperfect geometry of the datum part. And then that would define the datum feature, the imperfect geometry, would define the median, derived median line of the part. Okay, and that could be simulated by a chuck, which would close down on the diameter and then pick that up and center that up about your datum feature, your imperfect geometry of your datum feature. Okay, so that's how you would simulate a cylindrical part. So features of size. Datum features from parallel surfaces. Okay, what we're talking about here is a feature of size. This is, in this case, it's a slot, a rail, or a tab. That's this feature right here. Okay, we put the datum triangle in place of one of the arrows of the dimensions, so we know that this datum C is this slot, which is a feature of size. Really, so the datum, when we do it that way, the datum is really defined as the center plane. Okay, the center plane of that feature. So the datum feature symbol is placed in line with the dimension or applied directly to the feature control frame. You could do that either way. So what I'm saying there is you could take this datum C here, this datum identification, and you could put it right off the bottom of this feature control frame. And if you did that, you would have to put the arrow back in here. So this is about datum feature references in a feature control frame. So really this is the primary, secondary, and tertiary, and that's the selected order. For this part, that's perfect, okay, because the datum A is the largest surface on the part. And the other thing about datum A that makes it perfect for this is that it's used in this feature control frame, which locates the position of these two holes. And then when I'm manufacturing this part, I'm going to set this part on datum A because these holes are perpendicular to datum A. So if I'm going to drill these holes, I'm a tool designer, I'm going to come up with a fixture that holds the part, sets it down flat on datum A, so I can drill these holes. So that is a perfect selection. Okay, and so the part really dictates the order of precedence and how you're manufacturing the part. Now we could have other possible specifications depending on how the part is made, but they each mean something completely different. Okay, so in this case, A, B, and C is the best order for this part. A, C, and B would probably work, but what we need to understand is that each one of these is different than this top one up here. And that top one up here uses these three datums to establish a reference frame. Okay, order of precedence. The proper selection is very important. On the previous slide, the lower surface is chosen as primary datum A. The largest surface on the part will lay on this surface when the holes are manufactured, and the part will also lay on the surface when the hole location is inspected. Very important. Now, of the other two datum surfaces, the longer of the two datum edges is selected as datum B. The shorter of the two datum edges is selected as tertiary datum C. Therefore, the best datum precedence for this particular part is the A, B, and C. I'm going to end this movie right here, and then we'll come up with, we'll talk about slide 38 on the next one. Thank you.